This is a theatre. You have to find your seat, but you don't know where it is. If I tell you that your seat is on the left-hand side of the theatre, will it help? You can't, because there are so many seats on the left-hand side. Okay, now I'll give you one more hint. Your seat is in the B row. This makes your search easier. You have to go straight to row B on the left-hand side. But then B row has many seats. How will you know which one is yours? Right. I'll give you a final hint. Your seat is in row B, column 6. Can you locate your seat now? When two reference points are given, then it becomes easy to fix the exact location of an object on a plane. Now, if I draw the two walls of the theatre as two lines, A and B, intersecting each other at O, and I tell you that point S is 3 centimeters to the right of line A and it is 1 centimeter above line B, then we can locate a point on a plane if we know its distances from two mutually perpendicular intersecting straight lines on that plane. These intersecting lines are called axes. Let us find out more about axes and points.
Now, suppose instead of an ordinary line, we draw a number line x dash horizontally. We call this horizontal number line the x-axis. Next, we draw a number line y dash vertically. We call this vertical number line the y-axis. If these two number lines meet at right angles and intersect each other at their zeros, this is what we get. The point where the lines x dash x and y dash y intersect is called the origin and is denoted by O. On the x-axis, the negative numbers are on the left side of origin, while the positive numbers are to the right of the origin. On the y-axis, the negative numbers are below the origin, while the positive numbers are above the origin. The x and y axes drawn this way form the coordinate system. In the coordinate system, the plane gets divided into 4 quarters or quadrants. These quadrants have special names. They are the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Thus, any point in plane is in one of these quadrants, or on the x or y axis. For example, point P is in the first quadrant, point Q is in the second quadrant, point R is in the third quadrant, and point S is in the fourth quadrant. Point M lies on the y-axis. Point N lies on the x-axis. The point of origin O belongs to both axes. Take a look at some of the features of the coordinate system before we learn about coordinates of points.
Let's look at the 4 quadrants again. In the first quadrant, the values of x and y are positive. In the second quadrant, the values of x are negative and of y are positive. In the third quadrant, the values of x and y are negative. In the fourth quadrant, the values of x are positive and the values of y are negative. Let's see the coordinates of a point P. A perpendicular PN is drawn from P to the x-axis. We see that N is on number 3 on the x-axis. This number 3 is also known as the x-coordinate or abscissa of point P. Similarly, a perpendicular PR is drawn from P to the y-axis. R is on number 4 on the y-axis. This number 4 is called the y-coordinate or ordinate of point P. Each coordinate carries a sign depending on which quadrant it lies in. Since both the coordinates of P are in the first quadrant, the signs of the x and y coordinates are positive. Do you know that there is a special way to write the coordinates of a point? The coordinates are written within brackets. The x-coordinate or abscissa is always written first. For point P, the abscissa is 3. Then a comma is written. The y-coordinate or ordinate is written next. For point P, the ordinate is 4. Now let's see the coordinates of a point Q. We draw perpendiculars from Q to the x and the y axis. The point Q is in the second quadrant. The values of x are negative and the values of y are positive. Therefore, we can say that the x-coordinate or abscissa of Q is -5. The y-coordinate or ordinate of Q is +3. The x and y coordinates of a point are also known as the ordered pair for that point. For example, for point P, the ordered pair is 3, 4. For point Q, the ordered pair is -5, 3. Similarly, let's see the coordinates of a point R. In the figure, let's see the coordinates of a point S. Let's see the coordinates of a point N. Let's see the coordinates of a point M. Let's see the coordinates of a point O. So, we can see that given a coordinate system, each point on a plane has two coordinates, which is unique to that point. Look at this sheet of paper It is called a graph paper. A graph paper is writing paper that is printed with fine vertical and horizontal lines making up a regular grid. These lines are equally spaced so that the small squares are of equal size. We know that we can plot points on paper if we know the coordinates. Well, we'll use this graph paper to plot points and you'll see how easy it is. The x and y axis have already been drawn. The 4 quadrants have also been marked. There are 8 points given on the screen. Let us read the coordinates and plot the points. First, select the point you wish to plot. Click on a point in the table. Then plot the points in the graph by clicking on the correct coordinates. These are how we plot the points.
Do you know that we can solve equations with the help of a graph? Here's how. Say, we have an equation y is equal to 3x and we have to solve it graphically. We need 3 points to get an accurate graph. So, the first step is to substitute any 3 values for x and then find the corresponding values of y. If x is equal to 0 or 1 or minus 2, the values for y will be 0, 3 and minus 6 respectively. Make a table for the ordered pairs. Remember that the x and y coordinates of a point is called an ordered pair. The last step is to join the points. Don't worry, we will do it for you. What do we get? We get a graph which is a straight line. If the graph is a straight line, it means the equation is linear, or we can say that graphs of linear equations are always a straight line. All equations can be solved through graphs. That is why we can use graphs to solve simultaneous equations also. Here is how to do it. First, express one variable in terms of the other in both the equations. We get the value of y in both equations as shown. The next step is to substitute 3 values for one variable, in this case x, and find the corresponding values for y in the first equation. Form a table as shown. Repeat the same procedure with the second equation and draw the table. We substitute 3 values for x and find corresponding values for y. The two lines of the graph are the two equations expressed graphically. They intersect at point P. The x-coordinate of P is 6 and the y-coordinate is 2. Since both the equations are satisfied by the same values of x and y, the sum has been solved correctly.
Let us summarize what we've learned in this learning unit.